welcome to the second video for Unit 1 in our physics course. Today we are going to be focusing on equations of motion and position time graphs. This will be the end of the first unit per se. You'll probably have some type of unit activity that you will need to complete in conjunction with this particular video. Let's move on. Let's look at what we're going to be learning today. By the end of this video, you should be able to draw and use graphs to determine speed, velocity, and a position, use a motion equation to solve for a variety of variables, and understand acceleration and how it applies to velocity and motion. Just a reminder that this video is brought to you by Big K Diet Cola. Big K Diet Cola, all the taste, no calories. Big K Diet Cola. So we have the ability to visualize motion by plotting the position of the y-axis and time on the x-axis to create a position time graph for the motion. Recall that the formula for velocity is the change in displacement is the change in position divided by the change in time, or our final minus our initial, and same thing with our time, our final minus our initial. So we can look at this as almost like a slope formula, rise over run, correct? Different slopes represent different types of motion. So let's take a look at some examples here. I'm going to switch my pen color real quick. We start here at position 0, and then we end up at position 60. So our final position is 60. Our initial position is 0. Our initial time is 0. And it took us 10 seconds to get there. So that gives us a velocity of 6 meters per second. Okay? And it kind of makes sense because if we mention that this is essentially slope, that line has a positive slope. You remember that from your algebra class. If we look at the second part here, again, I'll use a different color. Okay. Our position does not change. So our final is 60. So is our initial. And our time changed. Our final time is 15 seconds, and our initial is 10. So what we get is 0 over 5, or 0 meters per second. Our slope is 0. And let's do one more just to make sure we have a real good idea on this. Let's do this last bit here. So remember, we're talking about displacement, not distance here. So our final point is at negative 40. Our initial is at 60. The time that's elapsed, our initial was 15 seconds, and our final is at 40 seconds. So what we end up getting is negative 100 over 25. So the velocity at that point is going to be negative 4 meters per second. Okay? So make sure that you're able to look and analyze these graphs to be able to determine different types of motion, as well as positive and negative, because remember, we're talking about velocity, we are not talking about speed. Speed and velocity are very similar, but velocity has magnitude of direction, which is why it has a positive or negative value. An important place to start in physics is always going to be an equation, and motion is no exception. Position can be described as a function of time. So given the formula, x of f equals xi plus v times t, where the final position is going to equal the initial position plus velocity times elapsed time. This actually looks very familiar to the formula for slope, and we can graph this position and figure out a bunch of material from it. Position time graphs intersect when objects have the same location. So if I were to plot this as a graph, I can tell when two particular objects, when they're coming right at each other with different velocities, would be able to intersect. They would intersect at the point where their final position, or x of f, is set equal to each other. That's going to be really helpful when we look at some of the practice problems here in just a moment. You and a friend are at the airport to catch a flight. Your friend is well ahead and seems sure to get to the gate first. Just then you spot a moving walkway going your way. At the moment you step on the walkway, your friend is 7.8 meters ahead and walking with the speed of 2.30 meters per second. Your speed on the walkway is 4.20 meters per second. Show that you catch up with your friend at time of 4.10 seconds and determine the location the two of you share at that particular time. So we're given quite a bit of information here. And a good way to always start out a physics problem is to be able to identify the information that you had. So let's take a look at me and my friend. There's an E in there somewhere. There you go. My fiend. The moment I step onto the walkway, so my starting point for this is 0 because everything is relative to me. My friend's starting point, however, is 7.8 meters. My velocity is 4.2 meters per second. And my friend's velocity is 2.1 meters per second. I'm sorry, 2.3 meters per second. Show that I catch up with my friend at t equals 4.1 seconds and determine the location that you two share at that time. So if I catch up to my friend in 4.10 seconds, I have all the variables I need to be able to solve for my final position, right? Because x of f, my final position, is going to equal my initial position plus v times t. And then I can solve for x of f, which is 17.2 meters. Sorry, it's hard to read. 17.2 meters. So let's check my friend's information as well, because he should be able to be at the same position in 4.10 seconds. So my friend, x of f, his final position, remember his initial is 7.8 meters ahead, plus his velocity, which is 2.30, times time, 4.10. I'm going to get x of f equals 7.8 plus 9.43, and you add those together, you roughly get the same final position. Okay? So all this is a matter of is just finding out information, looking at what variables you have, and then plugging in and solving. Make sure you're aware of positive and negative magnitudes of velocity as well. Two bumper cars move in a straight line with the following equations of motion. You can read those for yourself. Which bumper car has the greater speed? So remember that these two values here are velocity, right? Velocity has magnitude. That means that it can either have a positive or a negative value. Speed, however, is always a positive value. Think of the speedometer on your car. You drive forward or reverse, it tells you what speed it is going in any direction. So speed and velocity, remember that speed does not have a directional value. So here you have 1.5 meters per second in one direction and 2.5 meters per second going in the opposite direction. The bumper car number 2 is going to have the greatest speed, because remember, we don't take into account whether it is positive or negative when we are looking at speed. The last thing it asks is, at what time do the bumper cars collide? Well, if the bumper cars are going to collide, then their final position is going to be the same. We have our initial positions that are listed here. You've got your velocity here. You've got time. We just need to be able to solve for time. And since the bumper cars are going to collide, that means that x1 is going to equal x2. The final position is going to be the same for both of them. So we just need to set these equations equal to each other. And solve. I'm going to subtract 8.8 on both sides. It gives me negative 12.8 And then I'm also going to rearrange 1.5 as well. And then I just solve for t. So negative 12.8 over negative 4 equals t. .2 seconds is my final answer. Okay? So again, just keep in mind all the different stuff we can plug in. You'll get some practice problems to work on it this week, hopefully. Hopefully now you have a clear understanding of the concept of motion. You should be able to calculate and understand the concepts of velocity and speed. Use position time graphs to visualize changes in velocity over time and calculate position and constant velocity. Thanks again for watching, guys. Hope you guys have a great day. Make sure you like and subscribe. And if you have any questions, let me know. We'll see you guys later. Bye-bye.